Alrighty, welcome back to 105. Thank you for joining me again today. So today, we continue on our programming journey with something called if statements. Why do we need something like if statements? Well, it's because right now, the programs we write are very boring because computers are very stupid, right? Right now, we run our program. It always does the same thing. There is no variation whatsoever to it. So when you run your program, it starts executing at main, and it runs line by line. The input might be different, but that's about it for right now. And at the end of today's lecture, we're going to learn how to actually write useful programs. So the whole reason computers can actually do something special is because there is a way to conditionally run code. And if you do this enough times, your program actually appears smart. So in C, it's called an if statement, and it uses a Boolean. So we saw that type of Boolean is just either true, 1, or false, 0. So the syntax of an if statement, or the rules for writing it in C, is if, and then parentheses, and then an expression should go in there. And then at the end, it's a statement. So it should be some code that actually does something. However, you should always write it like if an expression and then curly brackets and statements. So these statements will only run if this expression is true, and we will see that is a bit. And just remember, an expression is just a combination of operands and operators. We're going to see some new ones today that operate on Booleans or produce Booleans. So the statements inside the curly brackets after the if only run if that expression is actually true. So C will compute the result of that expression and convert it to a Boolean. So remember, 0 is false and 1 is true. If the expression is true, then we will run these statements, all of them between the curly brackets after the if, and after those I run whatever the next statement is here after the curly brackets. If the expression is false, we immediately just skip everything in the curly brackets after the if and start executing right after the curly brackets of the if. So we don't actually run those statements if that expression is false. So the expression in an if statement, again, will convert it to a Boolean. There's more operators that result in a Boolean. You probably don't want a number to be implicitly converted with a Boolean. We'll see some examples of that. But you should use something called a rational operator. So relational. The relational operators work with numbers and produce a Boolean. So they are the following. So in C, if I write equal equal, then that's equivalent to just a single equal sign in math, and say whether the right-hand side is equal to the left-hand side. The reason we have to use equal equal in C instead of just a single equal statement like in math is because, well, we already use the equal statement in C, and that was to assign a value to a variable. So we can't use that. And in fact, one of the biggest programming errors you will probably encounter that might be a bit confusing is accidentally using equal when you should use equal equal. But nowadays, your compiler will try and give you a warning to say that, hey, you may be doing something you shouldn't be doing. So if I wanted not equals, well, I can't just write an equal sign with a slash on my keyboard. I have to come up with a different symbol. In C, if I want to write not equal, that is just exclamation point equal. So that means not equal in math. So that will return true if the left-hand side does not equal the right-hand side. And then again, there's less than, meaning less than. That is something you can actually type. And then if we wanted less than or equal to, then it's just a less than sign with an equal after that. So that means, less than or equal to in math. And then similarly for greater than, it's just, the other angle bracket in math. And if we want greater than or equal to, it is the same idea. We just put an equal character after it. So some examples in C. So this would be my expression to the left of the the yellow arrow here, and the final result of it to the right of the arrow. So if I ask C, is 2 equal to 2? That would be 2 equal 2. And in this case, that would be true. 2 indeed is equal to 2. So C is going to give me back a 1, signifying true. If I ask, hey, is 3 less than 2? The answer to that is no. So C will give me the answer, its answer or representation of no, which is 0 or false. And the way I still remember the less than sign, everyone in grade school, like they told you that, think of that as an alligator and the alligator wants to eat the bigger thing. Yeah, I have a PhD, I still remember it like that. So don't worry if you still have to remember that, it never really goes away. So yeah, the alligator would rather eat the 3, not the 2, so it is false. And then similarly, if I asked, hey, is 3 greater than or equal to 3? The answer to that is yes. They're in fact equal to each other. So the result would be 1 or true. All right, so the relational operators follow similar type rules to normal, like addition, subtraction, all that. If both operands are an int, it does the operator using integers. If at least one operand is a double, the other gets implicitly converted to a double if it's not one already. And the operator uses like the real numbers. So real numbers are numbers with a decimal point. But the result of either case is still a Boolean. It doesn't matter whether you do it on integers or doubles. The final result is always going to be a Boolean. So for example, if I ask if the integer 2 is equal to the double 2.0, well, the answer is going to be true, but it's going to do a bit of implicit type conversion. So it's going to convert this 2 as an integer to a double, so it'd be 2.0, and then 2.0 is equal to 2.0. So we get a 1 or true. All right. So there's also some operators that actually operate with Booleans. So these operators are called logical operators, and all operands are Booleans, and the result is a Boolean. So it's more of a way to tie together several Booleans to come up with a more complicated condition. So the logical operators are the following. So 2 bars means logical OR. So again, they're binary operators, so they need an argument on the left and the right. And the rule for logical OR is if either is 1, the result is 0. Otherwise, if either is 1, the result is 1. Otherwise, if both of them are false, then the final result is false. The 2 ampersands mean logical AND, so it's only true if both the left and the right-hand side are true. Otherwise, it's 0. And then just an exclamation sign, it's a unary operator, and all that does is a logical not, so it flips a value. So not true is false, not false is true. So here's some examples with that. So again, both the left and the right-hand side have to be Booleans. It's up to you. You can either use 1 or 0, or you can, if you include std bool.h, like we saw in lecture 2, you can use true and false just to represent 0 or 1 if you want. So in this case, if I do 0 or 0, well, the result of that is 0 because neither one of those are a 1 or true. If I do 1 or 0, that's how we would read it, then the result of that is a 1 because at least one of them is a 1. If I do 0 and 1, well, both of them are not 1s, so the final result is a 0. And finally, if I do 1 and 1, then the final result is a 1 because both sides are true. And then similarly, the not will just flip it, so not 1 is 0, and not 0 is 1. So questions about that? All right, after this, we can actually start almost writing funner programs. So again, rules for converting numbers to Booleans might be a bit weird. Let's see, what's our example? So, might be a bit strange. So, if C requires a Boolean, it will, like if it wants a double, it will implicitly cast your value. And how it works is, as a general rule, if the number represents 0, it gets converted to 0. Otherwise, it gets converted to a 1. So what would that look like? So that might give us some weird things. Oh, actually, no, I should not show that yet. Sorry. We'll get back to that. So just remember that. We'll see an example of how that gets weird in a little bit. So these operators follow precedence rules as before. Again, you don't really need to memorize this. Just know where they kind of fit in. So all of the relational operators that operate on number have a higher precedence than all of the assignment, or than all of them, sorry, have a lower precedence than the math operators. So they're done after them. So all of the math operations will be done first, like multiplication, division, mod, addition, subtraction. So all of them have a lower precedence. So they will be done after that. So all you really need to know is anything operating on Booleans will have a lower precedence, so they'll be done last. So these are the relational operators, and these are the logical operators here. So don't have to worry about them. If you don't want to remember these rules, easiest thing to do is to just put brackets around whatever you want to be done first in C, and that way you don't have to remember these rules. But typically, your statements or your expression should be fairly small, so you shouldn't have to worry about these rules. Otherwise, you're writing too much code. So let's write a fun little program. So now we can write a program that behaves slightly differently now depending on what the user inputs. So maybe I want to write a little program that actually tells me whether or not the number a user inputs is even or not. So I can define main like before. I can nicely ask the user to input an integer, create a variable for it called num, just in case I initialize it to 0. And then, of course, if we want input from the user from the terminal, we have to use scanf. And we want to read an integer, so we use the format specifier D. And we want to assign, or have C assign the value the user inputs into our variable called num. So we have to give it the address of, and then after that, the number is set. So now I can use my new handy-dandy if statement to check if the number is even. And one trick you'll see over and over again is if you want to check if something is even, easiest thing to do is to use the modulo operator. So if I do num mod 2, everything's an int, that will tell me the remainder of dividing the number by 2. If the remainder is 0, that means it's even, right? So it cleanly divides into 2. Otherwise, it does not. In this case, it should either return 0 or 1. And in this case, I just want to print off something if that number is even. Oops. So if I go ahead and run my program now, it's called isEven. It will ask me to input an integer. If I type something like, I don't know, 5, nothing happens. I don't see any output because 5 mod 2 is equal to 1. So 5 mod 2 is equal to 1, which does not equal 0. So this code will not run in the if statement, and it will just skip here and then do return exit success and exit my program. But if I run it again, give it a different input, maybe I say 6 this time, it will say the number is even, and now my program behaves slightly differently depending on what I input. So any questions about that little program there? Neat. All right. Everyone's good. All right. So here's the code again in the slides, just so you have it. And it's also in the examples repository you have access to. So here is kind of a diagram if you want to think about it that way. I can actually break each statement and like connect them all together to see which is going to run for an if statement. So you can actually get rid of the if statement itself and just kind of have a flow diagram as to what's going on. So whenever I run my program, it's always going to do printf, input an integer, declare a variable called num, and do scanf. and then it will always evaluate whatever is in the if statement, so whatever is in the parentheses. So in my case, oops, what was in the parentheses was num mod 2 equal 0. So it will evaluate that, and now it has a choice. We also call this a branch in programming. So if that expression is true, it's going to execute the statements inside of the curly brackets with the if, which in this case is just printf, the number is even. If it is false, it's going to skip to the end and just skip over that statement. So if the result of this, so that's why there's two lines coming out of the result of this expression. If it's true, it will printf, the number is even, and then go to the end of the curly brackets, which just does return exit success. And if it evaluates the false, it just directly goes to return exit success. It does not pass go, does not collect $200. So everyone okay with that as another way to represent what happens with an if statement? So it's basically a way to skip over some code or jump forward a little bit. So we'll get into the next lecture. We'll figure out how to jump backwards, and then that's as powerful as programs get. It's just more understanding problem solving at that point. So we've got one piece of the real programming puzzle. So other things we can do is, well, instead of just skipping over some code if the expression evaluates to false, maybe I want to run something different if that expression is false. So another valid syntax of an if statement is I can do something like if expression statement and then have something called an else statement. So in that case, if it's false, it will run the statements in the else branch. So you should always write it again with curly brackets. So I should write if expression, curly brackets, and then some statements that will only run if that expression is true. And now with else, I do else and then some curly brackets and then some more statements. And these statements will only run if that expression is false. So I can never run both of those statements at once. It's either one branch or the other. So again, the statements between the curly brackets after the else, again, only run if that expression is false. So now I can start writing some more neat programs. So maybe I can write a program now that actually tells me whether or not the number is odd or even. So I can just take what I wrote before that told me whether the number is even, and now, well, I can write an else branch that will print off that the number is odd if this expression is false, right? If that expression is false, then it will immediately fall through and print or start executing all the statements in the else part of the if statement. So it should print this number is odd and then return 0. In this case, I could write exit success again, but by this point, I kind of know that I saved myself some typing because I know that 0 means OK. So if I run this now, it's just called odd or even. Now, like before, if I type something like 4, it should immediately print off to me that this number is even, which is great. Or if I run it again now and type the number 5, now I see this number is odd. And it will only go into one branch or the other. So it will never print off the number is even and the number is odd. It's only one or the other. So any questions about that? All right, well, I'll come up with a question to you. So let's say I wanted to write my program a little bit differently. So maybe I thought about it in a way where maybe I want this if statement to be true if the number is odd, and then kind of reorganize my if statement. So if I do something like this, so I'll change it to check if the result of the modulo is equal to 1, and if it's equal to 1, then I'll say the number is odd. Otherwise, if it's false, I'll assume that the number is even. So should this do the exact same thing as I have written before? We got some head nodding. I just kind of flipped it on its head, right? So instead of checking if the number in that expression is even, I'm now checking if it's odd. So it should be true only if it's odd. Then I print off the number is odd, if that is true. Otherwise, I print this as even. So everyone agreed this should do the exact same thing. I just decided to write it a bit differently, right? All right, so this is also why programming is hard. So if I compile it and then I run it, build odd or even, then if I input the number 4, that should still be even, right? So 4 says this is even. 5 should say this is odd, right? It seems to do the exact same thing. Yeah?
So my question is, like, we flipped it around, right?
Yep.
And then, like, my question is, what if we don't equate it? What if we just say if num mod is 2? Would that do something?
So yes, one question is, what happens if I just do something like this?
Yeah.
So if I do something like this, this will work for the even case. So what this will do is num mod 2. So the result of that is an integer, right? Which should be either 0 or 1. And in which case, an if statement needs a Boolean, right? But 0 is false and 1 is true. So I don't actually have to write anything else. So this will return 0 if it is an even number, which would be false. So it's set up properly, but I'm kind of relying on conversion in this case, right? So if I do this, it should still work. 4, yeah, so it still works in this case, but I'm relying on conversion there. So instead, again, there's lots of ways to write programs. So maybe I do something like that. All right, so, yeah?
What's the difference between doing build slash and dot slash?
So the question is, what's the difference between doing build slash and dot slash? So dot slash means the executable is in the same directory you're currently in, and build slash means it's in a folder called build. So it just happens in this repository, I always put in a folder called build. I think in your code space for the lab, it's called mason-build, but same idea, it just goes to a different folder. It's just where that compiled executable is. All right, so you guys all said that this is like an equivalent program. Turns out this is actually wrong, and it outputs wrong number, or it outputs the wrong result, while the other one was always correct. Anyone want to hazard a guess why this program is now wrong? Yeah?
Does it have something to do with 0?
Does it have something to do with 0?
Like 0 mod 2 screws it up.
So maybe 0 mod 2 screws it up, so that's a good guess. Let's enter a number. 0 is even, that's fine. So 0 seems to work. Yeah?
Does it mess up with negatives?
Exactly. Remember all those weird, stupid mod rules that I told you about before? And how they're really, really weird, especially with negative numbers. So this works perfectly if your input is always, positive. But now, if I do something like, I don't know, negative 7. So negative 7. Everyone would agree with me that's an odd number, right? The number is even. Uh-oh, our first real bug. Why did that happen? Yeah?
The %2 is -1, no?
Yeah. So in this case, because it's a negative number, negative 7 mod 2 is actually negative 1, not 1. So just because of those stupid rules of C. So this is actually a fairly subtle problem. That doesn't appear if I do this. So turns out that if I wanted to actually check if the number was odd, well, I might get a remainder of 1 or -1. So if I wanted to properly do this and I didn't want to flip it on its head, I would have to use one of those OR statements, because the result of the mod could either be 1 or -1. So if I wanted to write that out, I would have to write the mod statement again and then So now this will be true if num mod 2 is equal to 1, or, again, it just has to be one of these is true for the whole thing to be true, or it's equal to negative 1. Yeah?
Is there a way to make it, like, force it to take the absolute value of num mod 2?
Yeah, so you could also do an absolute value if you want, but that's another function you probably have to look up in the math library or something else like that. So if I do that change, now -7 correctly says the number is odd. So just as a word of caution, if you want to check if a number is even, don't try and explicitly check if it is odd. Always just mod compared to 0, because 0 doesn't matter, right? Doesn't matter if it's negative, doesn't matter if it's positive. As long as the remainder is 0, thankfully there's no -0. So I would submit to you that this version that we wrote first is probably the better version, because we don't even have to worry about negative numbers. It just works for negative numbers, right? So if I compile that now and run it and do -7, it just immediately says the number is odd without any problems, because, well, the result of an odd number is going to be either 1 or -1. It will never be 0, so I don't have to worry about it. So sometimes it's better than, or some ways to write programs are better than others. So if you're checking an even number, you should probably always compare it to 0, or if you're checking if something is divisible by a number, always check if just the remainder is 0 and save yourself a bit of a headache. Ooh, that was a fun bug. All right, any questions about that? Yeah.
About your VS Code, why is that blinking?
Why is what blinking?
Your text cursor.
Oh.
How'd you do that?
Oh, my text cursor is blinking because I have a different input method and like keyboard shortcuts and some of that, so that's just from that. If you've heard of Vim before, I have Vim key bindings here. Yeah. All right. So just to illustrate this again, the logic for that, when we ran our previous program for even or odd, again, when we run main, these statements will always run in order. It will always ask us to input an integer, always declare num, always get input from the user, and then always evaluate num mod 2 equal to 0. But now because we have an else statement, we might actually run we might actually run different code if the result is false. So if it's true, we print the number is even, then go to success. And if it's false, we print the number is odd, and we go meet up at return edge of success. So we always meet up at the same place. So questions about that? That's how to visualize it. All right, cool. All right, so before we get into that example, so another weird gotcha here. So here's something about the implicit conversion to a Boolean. So if I write something like if 0.4, which is a double, it's going to get implicitly converted to a Boolean. So any guesses what happens if I actually run this program? Let's see, hands up, it will print true. No one. All right, hands up, it will print false. Flail your hands if you have no idea. All right, we got some flailing. Good. So let's just run it and see if we remember the rules. So it actually says true, which I think only one person raised their hands up. So why does it say true? Yeah.
I think any literal is always 1.
Any literal is always 1? Nope. So here, we can go back a bit in the slides. Let's go back a bit in the slides. So if C requires a Boolean, so it requires a Boolean for an expression, it will convert or cast your value. General rule, if the number represents 0, it gets converted to 0. Otherwise, it gets converted to a 1. The only way to represent 0 as a double is just 0.0. So that's the only representation of 0. Literally, any other value evaluates to true, which might be a bit confusing. So that's what. So 0.4, that does not equal 0. So it gets converted to the Boolean 1, and then we print off true. Yeah?
So for
Yeah,
We had like what was it? Num mod 2, right?
yeah.
So no matter what, that's going to print the right answer.
Yeah, so when we had nummod 2, like just nummod 2, so when we just had nummod 2, the answer was the integer 1 or 0, which just gets converted to the Boolean 1 or 0, so that's fine. That's easy to convert. But I explicitly put the equal brackets here because that was like relying on it getting an int converted to a Boolean. Here, if I do equal equal, the result is always a Boolean, right? So it kind of jives. So your type should always jive. So you should aim to have the expression in the if statement always return a Boolean. Otherwise, some surprising things may happen. All right, speaking of surprising things. So there was that. So let's see this example. So here, I'll just show you the code. So I write a new program, and I write, please input an integer. Again, like before, I declare num, get input from the user, and then maybe I have something like this. So I check if it's even, and then print if it's even, and then maybe I have another if statement here that checks if the number is 10 or greater. If that's true, then it prints the number is 10 or greater, and then else, the number is less than 10. So this is actually a bit confusing, right? Because I don't know what should actually happen. Which else does this, or sorry, which if does this else belong to? Does it belong to this if or this if? So if it belongs to this if, and I type a odd number, then it should immediately skip over this code and maybe go directly to the else. And for any odd number, it will print this number is less than 10. Or maybe what will happen is, I input a number. If it's even, it just prints this as even. Then checks, hey, is the number greater than 10? If it's greater than 10, and that's true, oh, well, it would print this. If it's false, then it's going to fall through and print the else statement. So the question is, if I accidentally, or well, not accidentally, if I input a odd number, will I see this line accidentally get printed and my program is wrong? Well, let's just try it. So here, would I call it 2 if else? So if let's say I input an 8, it writes the number is even and the number is less than 10. If I write something like 7, it says the number is less than 10 and immediately, and it doesn't say anything else. Well, there I can't tell which else it was connected to, so maybe I need to try a odd number greater than 10. So maybe 13. And if I do that, it says the number is 10 or greater. So something is going on here, and it is a little bit confusing. So the rule in C, unlike other languages, is this actually has a problem called the dangling else problem because it's actually not clear based off the syntax rules of C which if this else is connected to. If it's connected to this one or if it's connected to this one. Based off the inputs we actually tried and how it actually works, this else seems to actually be connected to this if because we'll never see both the number is 10 or greater and the number is less than 10 at the same time. So that is how C resolves the kind of ambiguity of it. This doesn't exist in other languages like Python that have like an elif or something like that. 1 second. So the rule is the else always applies to the f directly above it. Yeah.
That was the question.
Oh, that was the question? Yeah. So the rule here, the else always applies to the if directly above it. Yeah.
So there's no elifs in C?
Yeah, so there's no elifs in C. We can chain together if else, but there's no technical elif in C. So we have to chain them together. So we'll see that in a little bit too. So, oh, yeah.
Could you explain then how we would do like else if?
How you would do else if? Did I save that for, yeah, we can do that now. So, let's say I only wanted one of these to happen at a time, right? Well, to chain them together, technically an if statement is just a statement, right? And after an else, all I need is a statement. So if I want to chain together things, I could just write else if like that. So if I write else if like that, if this number is false, so if this is an odd number, this is false, right? So it's going to obey the rules and take the else branch. In this case, it's immediately going to execute this if statement. So it will check if the number is greater than 10. If the number is greater than 10, then it'll do this, print off this number, and then, well, it will fall through at the end and not take the else branch here, right? If this is false, then it will take the else branch. So that's how we can chain them together. Only one of these will ever run, ever, if we chain it together like that. So if you've done Python, this is Python just has a shortcut to make it prettier. This does the exact same thing, though. Yeah, did that answer your question? Yeah, it's kind of weird, though. But C, all about simple. They don't need an elif or anything like that. You can chain together else ifs if you want only one of them to go by. But technically, we just stacked up if statements, right? And of course, you can have if statements and if statements. So every if statement has two choices it could run. Inside, you could have another if statement, so that's another two choices. Inside those, you could have another two choices. Boom, exponential growth. And if you have millions of them, you have an LLM model, essentially. So LLM models are basically just, the if statements are a bit more complicated, and there's a lot of them, but same power you now have in your hands. So we can actually do something, actually no, so we can actually do something a bit more useful and create a fun little game that we can, start doing some gambling on. So let's start this number. So we learned about random numbers. We now learned about if statements. So we can actually go ahead and start betting because betting is fun. So let's make a game where we'll simulate rolling a die. So we'll simulate rolling a die, and then we're allowed to bet on the result of the die, whether or not it's odd or even. If we guess right, we win. If we guess wrong, we lose. So I can have the first line enter your bet. Just for ease, I'll just say even or odd, and I'll have the user input an integer. 0 if they want to bet for even, and 1 if they want to bet for odd. And then after that, get some input from the user, and then I can think about the rest of my program. So they should, again, I'll just assume that the user actually inputs either a 1 or a 0, so they're nice to me. So if I want to simulate rolling a die, I probably need a source of randomness, right? So the value of a die should be between 1 and 6, right? So anyone remember how I would actually get a random number between 1 or 6? So from last lecture, we had rand. Rand would return just a random positive integer for us always, right? So if I wanted to take the result of rand and kind of squish it into being a value between 1 and 6, what would I have to do to rand? Yeah. Yeah, mod 6 plus 1, right? If I remember everything, or even if I don't remember it, if I take rand and I mod something, I called it ramd, right, good spelling error. So if I take any number from rand and mod 6, basically I'm going to get that many different possibilities ranging from 0 all the way to 5. So that is the result of rand mod 6, some number 0 to 5. And then if I want to make it always be 1 to 6, all I have to do is add 1 to that. So, yep.
Could you just do rand mod 7?
So if I do rand mod 7, that's a good question. So what happens if I do rand mod 7? Yeah. Yeah, then I include 0, right? So rand mod 7, that's some number between 0 and 6 inclusive, but a die I don't want to represent 0. So 6, but that's a good observation. All right, so that should be a random die roll, right? So let's be fun. It's a game. So I'll just say we rolled a, and then number. So we can print to the user whatever we rolled, right? So let's compile that, run it as a game. So enter my bet. Right now it's not doing anything with my bet. Let's say just 0. And it says I rolled a 2. So it seems to work. That's a valid roll, right? So knowing what we know now, how might I check to see if the user has won? Or do they just always win? Because I could just print, you win, smiley face. So should I do that? Yeah.
Do the number mod 2 and if you get the same number that they input in the bet.
Yeah, so I'm going to need an if statement for this game, right? They can either win or they can lose. So I probably want to do something, show them that they're a winner or show them that they're a loser. So to do that, I need an if statement. And like you said, what you might want to check is we take the die roll. So it was in a variable called dice. We can mod 2. So that will give us, in this case, the die will always be positive. So it will always result in either a 0 or a 1. And then we can just check if it matches whatever the user inputted. So that's why I had them input 0 for even and 1 for odd, just to have it match. Of course, I could have flipped it around and then flipped my if statements, but this way I think just looks a bit cleaner. So I can open the brackets for the if statement, then print you win. So this should say I win, right? So it matches whatever I inputted. And then else, maybe I'm a bit meaner. So perfectly good game, right? So everyone agree that this is the beginning of a fun betting game. Everyone loves gambling, right? All right, so run my game. Enter your bet, 0 for even, 1 for odd. Well, I'll bet 0. I rolled a 2, I won again. Yay, cool, it's a game, right? So, run it again. Hopefully, I roll a different die number, right? Well, I'll just bet even again. 2. Oh, right, 2. Oh, I'm such a winner. Why is that? Well, because rand, remember rand's a pseudo number generator. So comes up with the same result every single time. I think I misspoke last lecture in saying sometimes it will randomize itself. Turns out we actually have to do that. So if I want to make this game a bit more fun, again, this is not something you actually need to know or something you need to program. Anything like this will be given to you. But if I want to introduce a source of randomness, remember I can set the seed using this srand function. And maybe I want to set the seed based off something more random. So one thing that is a bit more random is the current time. Hopefully it's not predictable. It's not the greatest. It is a bit predictable, but it is at least some value that's going to change. So there is a function called time that if I give the special value null, it will give me back the current time in the number of seconds. If I set that as my seed, it's actually going to be a bit different each time I run my program. Again, you don't actually need to know that function. This is just to make my game a bit more fun. You'd probably just look this up, figure out how to get a better source of randomness. And this is not the only source of randomness. So I have to compile again, of course, because this is C. So now I can play my game, and hopefully it's actually random and won't just have it 2 every single time. So I'll place my bet again. I'll say it's even, and I run it and rolled a 2. Okay, that was just lucky. I won again. I'll run it again. Run it again. I rolled a 1, and I'm now a loser finally. Cool, huh? There's a game. It's not that fun. Well, it's kind of fun, but I have to run my program every single time I want to play it right, and I can only play 1 round, which is kind of lame. So, next lecture, we'll figure out how to play multiple rounds without having to relaunch our program all the time. So I'll stick around for another 5 minutes, but other than that, I will let you leave early. So just remember, pulling for you, we're all in this together.